Okay, you guys, so we're going to do some more complicated examples of implicit differentiation. So notice that in this example, it's asking us to find the equation of the tangent line at the point 1, 1 on the curve y to the fourth plus xy equals x cubed minus x plus 2. So 1, 1, we are given that is a point that lies on that curve. And we need to, so we have the point, but we need to now find the slope of the tangent line at that point. And to be able to find the slope of the tangent line, we know we need to find the derivative of this equation. We need to find dy over dx. Okay, so let's show that we're going to differentiate each term with respect to x. Now this is going to be kind of a long example, so I'm going to add a page in now, just because I think I'm going to need some extra room. Okay, so remember, thinking chain rule. When we differentiate the first term, y to the fourth, with respect to x, chain rule, we would have 4 times, leave the inside function alone, now raised to the third power, times the derivative of the inside function with respect to x. So times dy over dx. Now here's where it gets tricky. We want to differentiate the product x times y with respect to x, which means we need to use product rule. So I'm going to use brackets to keep my product rule organized. Okay, so product rule, remember product rule is we take first function, or the first factor, times the derivative of the second factor plus the second factor times the derivative of the first factor. Remember that addition and multiplication is commutative, so those two products can be switched around and the factors could be switched around. But this is the order that I'm going to follow. So I'm going to write down the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor, which would be dx over dx, and that's why I'm just writing 1. Okay, not too bad, right? Okay, derivative, now we're on the right-hand side of the equation. Derivative of x cubed with respect to x is just 3x squared minus the derivative of x with respect to x would be dx over dx, so it's just minus 1. And then the derivative of 2 is just 0. Derivative of a constant is 0. So let's just clean up the left-hand side. To rewrite without the brackets, I don't need those. Now we need dy over dx by itself on one side of the equation. So I want all my terms with dy over dx on one side of the equation and all the other terms on the other, so that then I can factor out a dy over dx. So I'm going to subtract y from each side. And now we're ready to factor out a dy over dx on the left. And to finish isolating dy over dx on the left-hand side, we can divide by 4y cubed plus x. Okay, so we have a point. We need the slope of the tangent line at that point. So the slope of the tangent line will be evaluating dy over dx at 1, 1. So I can substitute 1 in for x and 1 in for y. So that'll be 1/5. Okay, so the equation for our tangent line at that point, at the point 1, 1, will be y minus 1 equals to 1/5 times x minus 1. Okay, so we found the equation of the tangent line at that point to that curve. Okay, let's try this one. This is just asking for dy over dx. So let's show that we're taking the derivative of each term with respect to x. Please show this step in your work. Okay, so notice we are taking the derivative of x times y squared with respect to x. So we're taking the derivative of a product, which means we have to use product rule. I'm going to use brackets to organize my product rule. So again, I'm following product rule is f of x, so first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. So x times 2y, now to the first power, times the derivative of the inside function, thinking product rule, so dy over dx, plus y squared times the derivative of the first factor, which would just be 1, dx over dx, which is 1. Okay, we have another product we're taking the derivative of. X squared times 5y to the 4th times dy over dx plus y to the 5th times 2x. Okay, minus the derivative of x cubed, so 3x squared, equals to the derivative of 3, which is 0. So I'm going to clean up the left-hand side, pull the constants up front when possible. I apologize for not giving you guys more room for the examples. We are definitely going to need another page. Okay, so now let's have all the terms with dy over dx on the left side and move all the other terms to the right side. So 2xy times dy over dx can stay on the left, so can 5x squared times y to the 4th times dy over dx. And then on the right-hand side, we'll have 3x squared minus 2x y to the 5th minus y squared. So on the left side, we can factor out that dy over dx. Okay, and then to finish isolating dy over dx, finito. Guess we didn't go that much over, I could have just resized. Okay, this one's kind of tricky. So we're finding the equation of the tangent line again. We need to find dy over dx to help us find the slope of the tangent line. So this is x times y to the 1/2 power, right? Square root of x times y is the same as x times y to the 1/2. You're going to pull that constant out front. That one too. Now, there's two ways that you could go about. So before I start, there are two ways you could go about differentiating this term. We could think chain rule, where we're going to have to multiply by the derivative of the inside, and to multiply by the derivative of the inside, we'd have to use product rule. Or you guys remember your rules of exponents, where if we have a times b raised to some power, that's equivalent to a to the m times b to the m, where you apply the exponent to each factor in the product. So we could think of this as d over dx. I'm not going to rewrite this actually. So we could leave this like so. Or we could rewrite as x to the 1/2 times y to the 1/2, where then we're applying product rule. I think I'm going to leave it, just because I think that way, I'm going to leave it as x times y to the 1/2. Okay. So here we go. Derivative of x squared with respect to x would just be 2x. So now minus, thinking chain rule, 1/2 times x times y, I'm leaving the inside alone, to the negative 1/2, times the derivative of the inside, which we need product rule for. So x times dy over dx plus y times 1. Not too bad. Okay, equals 4y times dy over dx plus 3. Okay, so I'm going to distribute this in because we need to get all our dy over dx's on one side of the equation, and so I need to take care of the product here. So we'll have 2x minus x over 2 times the square root of x times y. I'm rewriting x times y to the 1/2 as the square root of x times y, times dy over dx, plus y over 2 times the square root of x times y, okay, that stays the same. Okay, so now I'm ready to get all my terms with dy over dx on one side and the other terms on the other side. So I'm just going to add this term to each side of the equation, and I'm going to subtract 3 from each side of the equation. That'll be fastest. So 2x minus y over 2 times the square root of x times y minus 3 will be equal to 4y times dy over dx plus x over 2 times the square root of x times y times dy over dx. Give myself a little more room. Okay, so now on the right-hand side, left-hand side will stay the same. On the right-hand side, I can factor out the dy over dx. And divide by the quantity, 4y plus x divided by 2 times the square root of x times y. So we're going to have some complex fractions. Okay, we don't want complex fractions. So to get rid of the complex fraction, let's multiply by 2 times the square root of x times y over 2 root xy. So we'll get dy over dx is equal to 4x times the square root of x times y, which could be simplified more, but I'm just going to leave it like that, minus y, minus 6 times the square root of x times y, over 8y times the square root of x times y, plus x. Okay, so we're finding the slope of the tangent line at 4, 1. Okay, so let's substitute 4 in for all the x's, 1 in for all the y's. So that'll be 32 minus 1 minus 12. And then over 16 plus 4. Okay, so that's our slope, 19/20. So our equation, y minus 1 equals to 19/20 times x minus 4. So that's the equation of our tangent line. All right, last one. This looks like a bit of a doozy. So we're taking the derivative with respect to x. I'm going to rewrite this as x plus y to the 1/2. You're going to rewrite 1 over x as x to the negative first. And 1 over y as y to the negative first. All right, so to find the derivative of the left-hand side of the equation, chain rule. Right, so derivative of the outside would be 1/2, and then the quantity x plus y to the negative 1/2 times the derivative of the inside. The derivative of x would just be 1, and the derivative of y is dy over dx. Okay, thinking we can just use power rule here. Okay, clean this up a bit. I'm distributing this quantity. So 1/2 times x, let's rewrite without negative exponents. So 1 over 2 times the square root of x plus y plus 1 over 2 times the square root of x plus y times dy over dx equals negative 1 over x squared minus 1 over y squared times dy over dx. So let's get all our terms with dy over dx on one side and all the others. So I'm going to do left-hand side the terms with dy over dx. Okay, so we can factor dy over dx out on the left side. Okay, so dy over dx is equal to negative 1 over x squared minus 1 over y squared minus 1 over 2 times the square root of x plus y, all over 1 over 2 times the square root of x plus y plus 1 over y squared. And we have complex fractions. So let's get rid of those. We need to multiply by a version of 1 to clear those complex fractions. So we want to multiply by the LCM of the denominators of those complex fractions, which it looks like will be 2x squared y squared times the square root of x plus y. Okay, so let's look at the numerator first. When we distribute to the first fraction, the x squareds will cancel and we'll be left with minus 2y squared times the square root of x plus y. Then to the second fraction, the y squareds would cancel. And in the third fraction, 2 times the square root of x plus y would cancel, so we'll be left with minus x squared times y squared. And in the denominator, x squared y squared plus 2x squared times the square root of x plus y. Oh, that's it. We just had to find dy over dx. And that's